Today we're going to be talking about section 5.2, solving problems by using right triangle models. There's a few ideas I want to get across with this lesson. When you encounter trig problems, the best thing to do is try and draw in right triangles when possible. And then once you have a right triangle, you can then use any of the primary trig ratios that's applicable to the question. And you'll see what I mean as we go through these notes. If I go to the next page here, I've drawn in a triangle and I've labeled it A, B, and C, and I've labeled the corresponding sides that are opposite to these angles, little c, little a, and little b, that correspond opposite to each angle, and I've labeled the height, so I've drawn in a perpendicular bisector here to denote the height. And you can use any of these angles to determine or to get an expression for the height. So what I've done is I've used this angle, angle C, to find an expression for the height here. So sine of angle C is equal to the height, which is the opposite side, divided by A, which is the hypotenuse of this triangle on the right-hand side. And if I isolate for h or solve for h, I get this expression. It is the length of A times the sine of angle C. Okay, and how this is useful is if we're going to calculate the area of the triangle, you can use the sine ratio. So essentially what I've done is I've used the sine ratio to determine the height, and this is based on the information given, knowing the length of A, the length of B, and the angle of C. So now, simply what we're doing is now I'm taking this expression over here and I'm substituting it into this expression, area equals 1/2 base times height, which is the area formula of a triangle. So when I replace the h with this expression over here, you now get the area of the triangle is 1/2 the side length of B times A times the sine of angle C, all in brackets. Now let's look at an example. This is question number 1A from page 280. I've already drawn in the diagram from the textbook. They give this side, which would be little c, is 5.5 centimeters, and this side, which is little a, 6.0 centimeters. We know that angle B is 30 degrees, and in order to find, we're asked to calculate the area to the nearest tenth. So in order to find the area, we need to find this height. Well, the height, again, we can use sine law. So sine of 30 degrees is equal to h divided by 5.5. If I multiply both sides by 5.5, now I've isolated h, and this is 2.75 centimeters. Once I have the height, I can now calculate the area. So let me scroll down a bit here. Therefore, the area is 1/2 base times height, 1/2 times 6.0 times 2.75, and I get 8.25 centimeters squared. Now I want to take a look at example number 1 from the textbook on page 274. The question reads, a surveyor stands at a point S, so here's the point S, and uses a laser transmit and marking pole to sight two corners, corner A and corner B, on one side of the rectangular lot. The survey marks a reference point P, so here's reference point P, on the line AB, so that the line from Q to S is perpendicular to AB, and that's how I'm able to draw in the 90-degree symbol there. Corner A is 150 meters away from S and 34 degrees east of P, so this should be 34 degrees. 34 degrees east of P. And corner B is 347 meters away from S, and it's 69 degrees west of P, so 69 degrees west and I've given the directional symbols here. So essentially what the question is asking, they're asking is how long is this lot? So i.e. the distance of AB. So they want this whole horizontal distance from A to B. Well, we now have a situation where we have two right triangles. So let's separate the two. So if we look at sort of, triangle APS. So that's APS, this triangle here. Okay. I'm going to use cos. Cos theta is equal to little a over the hypotenuse. So here's little a, and here's the hypotenuse. So the hypotenuse is 150. So if we fill in some of this information, so cos 34 degrees is equal to the length of PS, divided by 150. Okay. I'm going to multiply both sides by 150. Okay. Therefore, the length of PS is going to be 124.356 meters. Okay, so if you multiply 150 times cos 34, you end up with this 124.356. Now I want to find the length of PA, which is this distance here, P to A. I'm only finding a partial distance of all the way of this whole lot. Okay, and we can use the Pythagorean theorem now. So the distance of AS squared, this is AS squared, is equal to the length of PS squared plus the length of PA squared. And now we can fill in some of the unknown values. 150 squared is equal to 124.356, which we just found, squared, plus PA squared. Let's rearrange this. So that means PA squared is equal to 150 squared minus 124.356 squared. Okay. PA squared is equal to 7,036. If I take the square root of both sides, PA is approximately 83.8808679 meters. At this point, if you want to take some time to pause the video, just so that you can record these notes, because right now I'm going to erase some of the code or some of the solution here, just so that I can keep the picture or write the next steps so that I can still use the diagram. Okay, so I'm going to erase all this. Now I want to look at, so if you want to sort of say that this is sort of the third calculation we're making, I want to look at triangle BPS. So here's BPS, this triangle. It's the left right triangle now. We can use the Pythagorean theorem. So BS, the length of BS squared, is equal to PS squared, this is an S squared, plus BP squared. Let's fill in some of the numbers. 347 squared is equal to 124, which we found in step number 1. 356 squared plus BP squared. BP squared is 347 squared minus 124.356 squared. squared is equal to 104,945. Again, I take the square root of both sides, and b2 is equal to 323.952,157 meters. Finally, I need to determine now. So in step number 2, I determined what this measurement was. In step number 3, I determined what this measurement was. So now, in order to determine what the full length of the lot is, I just simply have to add the two together. So the length of AB is 83.8808679 plus the 323.952157, and this ends up equaling approximately 408 meters. Okay. So again, just make a concluding statement. Therefore, the lot is approximately 408 meters long. Okay. So this concludes this lesson. However, remember, like I instructed you guys in class 1, I want you to make notes. 2, summarize some key points. And when you come to class tomorrow, come to class with some questions. Again, like I mentioned, I will be doing a homework check, and this will be part of the homework check. And have a good evening.